Session 3 and 4 taught by Dr. Reams in Black in 1977. This is tape 18 side A.
Now, do you talk there? This is logarithm. The copy may be heard by requesting tape number 18-6, slant 27-7, slant 1-77.
I only used it in the compound state to show you the principle of converting any number to its lowest common denominator to logarithms. That is one system of converting it down to its lowest common denominator. Whenever you take hot water and cold water and put it together, it reaches this level of temperature. So this is called synchronization. Or when two motors are running and one is running faster than the other, but both of them are trying to pull a propeller maybe on an airplane, the plane will have a tendency to try to turn around because one is not pulling as hard as the other, and it's not synchronized. But when they synchronize them and the pitch of the blade is the same, then the tone of the engine is different and the plane sails very smoothly. So you will find a synchronization throughout all nature. All nature, it seeks to synchronize. Now that synchronization will follow the line of least resistance. Now if it follows the line of least resistance, if you can see through the next statement that I'm going to say, then it would be impossible for an atom to contain the same number of protons as neutrons. It would be utterly impossible. In other words, that explodes that theory completely because it couldn't be. Because you'd have a ratio of 1 to 1, it doesn't matter what you mix, you'd still come up with the same substance. Is that clear? Do you see through that statement? If you don't, listen, the only way in the world to get rid of ignorance is to expose it. And I always enjoy exposing my own ignorance because that's the only way I learn. Yes. Protons is neutrons. It does not, even though the chemistry book says so. Everything that has a ratio of 1 to 1, and the things that follow the line of least resistance would all come out as hydrogen. A proton is an electron. A proton, I was taught, was a positively charged ion. Electron was a neutron, electrically charged. That's what I was taught. I didn't know they'd changed it. Now this, I know this is difficult for you, and it's very easy for me because I've used it every day for over 50 years. And if anybody can help me to make this, or to explain this to you, anyway, I would appreciate your help, because to me it's just as easy to hen laying an egg. You just can't help it, yes. That's right, just one. That's the energy that you would figure in the smallest particle of energy of any one element. Any one compound, I beg your pardon, any one compound. No, you may come out with 1.2 or 1.3, or you may come out with 8.8 or something like that. Whenever we start tomorrow with actually putting a molecule together, then you'll see why they come out differently. But today we're only trying to explain to you the principle of logarithms. This is all I'm trying to get across this afternoon. The whole afternoon is the whole principle of logarithms. Now, I'm going to repeat again that in relative math you do not deal with zeros, and you don't need them really in logs. For instance, I will put a problem here and just show you something. For instance, suppose you have a 1, which is the right one? 1. They don't write either.
No, that won't work. There has to be someone walked off with Just go on to the gentleman.
Thank you. Okay, 1. Okay, we've got a 1 and a 0 and a 2, 5, but there's a decimal here. 1.025. So if you want to convert that to a log, you can write it 1.25. The 0 doesn't add anything to it at all. Not in relative math. Not in relative math, the 0 doesn't add anything to it. Doesn't change it at all. Because a 0 in relative math is a 0. It's nothing. So whenever you begin to deal with your atomic structure, the atomic elementary structure of a molecule, the variables will cause it to synchronize into a substance, a compound substance. And we're dealing on one frequency, which in this course we will not even compare the frequency with the manufacture or the making of one molecule. All we want to do in this course is understand what one molecule does. And tomorrow, for a part of the day, we're going to take how one molecule is made, and then we're going to leave that completely, and then we're going to take problems, and the rest of the day tomorrow and all Friday, we're going to describe the person from the problem with the basic understanding of energy that you have here, and give you time to study this until we hit course 5. But I hope and pray that you won't try to put 5 and 6 together, because you're going to run into just what you're running into here. It's too heavy. It's too much to try to comprehend at one time. The human mind just can only take so much. And try to keep these 2, 3 months, 4 months, or even 6 months apart to work on it. And don't be afraid to get a private teacher to teach you about logarithms or to teach you about cell structure. Now, we're not dealing with the cell. We're dealing with the parts of energy that it takes to make an element, which a cell is made out of elements. 2 or more elements is one compound. 2 or more elements is a compound. Okay? An element is all of one substance that is synchronized, like iron, gold, carbon, zinc, nitrogen, phosphorus, kalium, calcium. I'm talking about in its purest states. But when you get into calciums, there's a variable, and you get into potassium, there's a variable. So you don't have to be absolutely accurate like the teacher in the 1st grade or 2nd grade or 4th grade, adding 6 and 4 equals 10. You don't have to be near that accurate, so long as you can get as near accurate as the man that reports the weather. You're doing pretty well. Because that will show you whether or not the body chemistry is moving towards range 1. Now, you should have these ranges memorized. I mean, memorize those ranges so you know them and know which range you're in and how far you've got to go and its variables. Did you have a question? You need to memorize these things, and the more memory work you do of these principles that we're giving you, and we're cutting out all of the adjectives and all of the everything but the main way of reasoning this thing through. Your logarithm is converting a large number to its smallest known denominator. Now, there's many ways to solve a problem. Anybody tells you that there's only one way to solve any mathematical problem doesn't know very much about mathematics or physics or anything else for that matter. There's only one way. If they only know one way to do it. It's kind of like when you first move into a new city. You learn one way to the depot, so to speak. And then you follow that, but later you take another route and find a way and another way and another way and another way and another way until you learn your whole community how to get around over it. And it's the same way in math. There's many ways to solve the math problems. But one of the things about dealing in solving the problems there's many different ways to solve the problem, but the thing about it is the problem should all come up, all people working on the problem should come up with the same answer as to what problem you're going to solve. Do you see what I'm saying? In other words, all of you should agree on what problem needs to be solved, but it doesn't matter which form of math or which foods you use to solve it, just so it does it. Have I made myself clear? Now, so many people think that if Dr. Black says, do it this way in solving the problem, and I say, do it this way, that there's a division. No, there's no division. Only he chose one way to do it, and I chose another. But so long as the numbers are moving back toward perfect, both of us are correct. But if my way caused the numbers to move away from perfect, or vice versa, then one or the other would be wrong. You see what I'm saying? In other words, it's so easy to think that there's a division in thinking, and when it's all in the way the problem is solved. For instance, you may think in geometrical math that a straight line is the nearest distance between 2 points. In geometrical math, that's true, but in relative math, it's not true. I'd like for you to see you to go from here straight to Moscow or to Hong Kong. You can't go straight through the earth. That's the nearest distance. So you have to go around, kind of like the little frog, you know. The little frog on the edge of the pond was saying, too deep, too deep, too deep. And the big frog in the middle of the pond was saying, go round, go round, go round. So that's an example of relative math and geometrical math. In other words, you can't go straight to Moscow from here because you'd have to go through the earth. So you have to go relative math. You have to go around. You begin to see the difference now? So, for instance, here's another problem. In traveling from here to the moon, the men that went to the moon, do you know that they traveled in the same direction going from the moon back to Earth as they did from here to the moon? Did you know that? If you hadn't, they'd still be out in space. They did not turn around and come back the same direction. If they had, they would have been still in space out there. They'd have missed the Earth completely. Why? Because of the orbit. That is exactly right. They had to keep a straight line or they would have missed it. Is there anything difficult to see about that? The difference in geometrical math and relative math? Do you see that? Now, also, whenever the rocket was shot off from the Earth, it had to make 2 or 3 circles around the Earth before it could take off to where the moon was going to be in its orbit when they got there, or else they would have missed it. It would have been over on the other side of the Earth. This is geometrical math. This is relative math. It travels in circles. Now, Halley's Comet makes a circle big enough, and it's traveling at a terrific rate of speed, and it takes it 75 years to make its complete cycle. And it's due back in 1985 to be back to make its cycle, to be visible to the Earth again in 1985. The last time it was 1910. I was just a little boy, but I remember seeing Halley's Comet. And I was just a little boy, 7 years old, and how far it was away, and that star with a tail, and how, if you would watch it for 2 or 3 minutes and can keep your eye on it in the night, you could tell that it was moving, and you could tell that the tail was not always straight. It was not traveling in a perfectly straight line, but a near straight line. So, are you getting a mental vision of the difference between relative math and geometrical math? I said to you the other day that in geometrical math, parallel lines never meet, like a railroad track. But in relative math, they not only cross once, but they cross twice before it makes the complete circle. Now, when man went from here to the moon, and then traveled in the same direction back to the Earth, he did not complete the circle. He just went from one point to another. He did not complete the cycle. So these cycles, and after you get outside of the Van Allen belt, are quite large. Now, remember also that in biological life, in plants, they are not controlled by glands, but animals are controlled. The higher animals are controlled by glands. But we have approximately, or to be exact, if we are perfect in our structure, we have 284 glands in our body. And we also have 284 taste buds on our tongue. And these are very, very important to distinguish taste and flavors and so forth. So each of these is an electrical response. The taste and smell is a short circuit of a nerve ending giving us a response of flavor or odor. It is a short circuit of a particle of energy that gives us the flavor that we're tasting or the odor we're smelling. Now these are energy particles. Have you ever tasted something? I mean, let me ask it this way. Have you ever held your nose and where you couldn't smell it and then taste something and try to describe the flavor? It's very difficult. Very difficult. In other words, the odor and the flavor are synonymous. Very synonymous. I have taken a grape drink and a Coca-Cola and ginger ale and blindfolded people and had them to hold their nose and taste them and see which one could pick out which was which, and they couldn't do it. They could not do it. Now, children that drink a lot of it can do it better than adults. The children get some of them right, but the adults that knew what the flavor was could not do it. So what I'm trying to tell you is that the less taste you have, the lower your energy rating is. The less smell you have, the lower your energy rating is. However, there may be people with a good smell and a good taste, very sensitive, that still has a lower energy rating than you have. So you cannot compare your health and your life with somebody else's. Therefore, the process by which your body chemistry is brought back to zone 1 is different one from another. However, there's an overall principle that we try. It doesn't always work, but it's a principle. And that principle lies within the liver. Now, within the liver, there is a process there in which the liver manufactures about 6 billion different enzymes. And an enzyme and a vitamin is the same thing. We think of a vitamin as being man-made and an enzyme as being made by a hormone. And inside of the hormone, there is life. If there's no life in the hormone, then it's not a hormone. Now, we have selling in the drugstore what they call hormones. That are hormones, they are stimulants, but they're not really hormones. However, we do eat a lot of food that have hormones in them. Now, this has a lot to do with relative and geometrical math, as you're going to see in a few moments. If I ask you to go to the store and buy some live hormones, what would you bring me? Cheese is one? Yogurt's another? What's that? Yeast is another? Well, wheat germ may or may not have. Kefir is another? What's that? I wouldn't know. But some royal jellies are, but some aren't. I've never tested the beef powder, I don't know. But buttermilk, yes. Right? Eggs, those things are living hormones that we eat. Actually, when we eat cheese, we're eating little bugs, bacteria, bugs. Now, our cheese is not any more milk than milk is grass. Actually, cheese is a meat. In other words, we're eating a protein meat. if it's made from skim milk, it has less than made from whole milk, the proteins. But what we're getting into now is the variables whenever you put food in your stomach, and they begin to synchronize each other. What happens? How do you figure it? Whenever there is in our bodies approximately, we'll say 70 or 80% water, and when we don't drink enough water, you can see the trouble we're getting in. You can see how we get into trouble. Some people come to me and boast that I never drink water. And my question is, what do you think you are, a Volkswagen? In other words, it's the water that makes it possible for our body to assimilate these elements. Now, in its anionic form, and the liver rejoins, in other words, the stomach, gives off two kinds of energy, electrical and heat energy, and that collects in the liver, and the liver then manufactures it into an enzyme that fits our body organs, that then puts it into the blood and into the stomach, and some of it picked up by the stomata of the stomach, and some of it through the intestines, some of it through the bacterial action of the intestines into the bloodstream, and then it goes out to the various organs. And if that organ, if that part fits that organ and is a cell worn out, it is attracted to that organ by magnetic attraction, the element, in very small form, and in the stool of the atom, and the stool of the molecule, that then sheds off its shell and grows a new one in its place. And this cell then goes into the bloodstream, it goes out through the kidneys, and therefore you remain in good health. But if this molecule that's worn out, or this delta cell that's worn out, stays in the bloodstream for 3 days, then nature, the salt in your system, will start purifying that cell, separating it, dividing it into a liquid, or it's a salt that can be dehydrated out into a salt. And this salt is protein, which causes the heart to beat too hard and brings about a loss of energy and premature aging, fatigueness in the morning and tiredness in the morning. So these are the results of the energy being released from a single molecule. But we're studying this afternoon how these molecules are made. The reason I'm telling you this is to show you where these logarithms fit into the program. And Dr. Black told you the other day that there's approximately 4 pounds of stools within our body, if it's quite muscular, for 100 pounds of weight. And in these stools, it carries the frequency of our bodies, either 24 or 26 log frequency. And therefore, when we begin to think in the units of power that will cause the food we eat to give off sufficient energy in forms that are usable by the liver to manufacture the parts for our vital organs, then we can understand the why and the wherefore, the why and the wherefore of the need for logarithms. The higher the number of electrons in orbit in any substance, the stronger must be the gastric juice of the liver in order to attract those, or to snatch those off, or to divide those, or to put them into a usable molecule or a particle of energy, not necessarily a molecule, but a particle of energy that can be ionized on the log frequency of your body, whether it be male or female. So in a child, the gastric juices are more dilute than in an older person. In an older person that's very ill, the gastric juices are dilute as in a child. So when you begin to think the whole round picture, you come right back to how much, what kind, which one, and when, or how, when, and where. Yes? Right. That's right. A greater specific gravity, yes. What's that? Well, that depends on water, your weight, your age, your height, your sex, your race, and so forth. This is why it makes energy so difficult to figure, because you've got so many factors. Most people can solve a problem if there's not over 3 factors. But whenever you run into 2,600 factors or 26 to the 26 power factors, then you run into problems. You run into great problems. Let's go back to our log table now.
Now's the time to turn tape over. Isn't Jesus wonderful? Have you told him you love him today?